Hey guys, Mr. Middleton here. Today we're going to talk about perimeter and area ratios. At the end of this video, you should be able to find the similarity, perimeter, and area ratios of two similar figures and determine when to use each one. And then you should also be able to use similarity, perimeter, and area ratios to find missing information in similar figures. Alright, so first things first, let's talk about this. If the similarity ratio of two similar figures is A to B, then the ratio of their perimeters, hopefully you've seen this through our practice problems throughout the chapter, is the same. It's the same as A over B, or A to B. Okay, I'll probably write it as a ratio because it looks better. Okay. Now, the ratio of their areas will not be the same. The ratio of their areas will be A squared to B squared. Okay, so let's take a quick second to look at, let's just say, two rectangles that I'm going to draw up here. Let's say 4 to 2. Okay, and I'm going to make this one, we'll just say double that size, 8 to 4, right? Okay, so you'll see that these are similar rectangles or similar figures. Let's say that. Okay, their ratios are 1 to 2. For every 1 here, there's 2 here. We can tell that by just putting corresponding sides together and simplifying. That's the ratio. Okay, if we look at the perimeter of these figures, the perimeter of this figure would be 8, 10, 12. Perimeter is 12. The perimeter of this figure would be 16, 20, 24. So notice that the perimeters will be 12 over 24, which is, again, 1 to 2. Now, if we look at the areas, though, the area of this figure will be 4 times 2, which is 8. A unit square. The area of this figure will be 4 times 8, which is 32. Okay. Now 4 over 32, or sorry, 8 over 32 will simplify to 1 over 4. Okay, so notice it's A squared, which is 1, over 2 squared, 4. Okay, so a very simple example, but that is where we get these ratios. Okay, so here's the ratio of perimeters in practice, and here is the ratio of areas. Okay, so one example could do a lot more because it's a relationship that stays true, but we'll move on from there into other examples. So here we go. The trapezoids below are similar, so they're already telling us that it's similar. We don't need to prove it. What is the similarity ratio? Remember, the similarity ratio is just the corresponding sides over each other simplified. So we have 6 over 9. Simplify that. That gives us 2/3. 2/3. What's the perimeter ratio? Well, remember that the ratio of the perimeters is the same as the similarity ratio. So if the similarity ratio is 2/3, then the perimeter ratio is 2/3. What is the ratio of their areas? Okay, and now here's what we have to remember. The ratio of their areas is no longer 2/3, it's now 2 squared over 3 squared. We will not want to write our final answer that way. We will want to say 4 over 9. Okay? Alright, so now looking at that information, we'll go past that into using that information in order to find out more information in the triangle, or unknown information in figures, not necessarily a triangle. So example 2, the pentagons below are similar. The area of the smaller pentagon is 30 centimeters squared. Find the area of the larger pentagon. Really important words here, that they're telling us that their area, okay? Also that they're telling us that they're similar. Okay, and so we know that the similarity ratio will play a part here. These are similar, their corresponding sides, 4 and 10. So I'm going to take those sides, and I want to find my similarity ratio. This is my similarity ratio. Now, like I said, it's really important that I know that we're looking for area. Area ratio, remember, is A squared over B squared. So to find the area ratio, I need to go from 2 squared over 5 squared, or 4 over 25. This is the ratio that we're going to use because we're dealing with area. And so we're going to use this ratio to set up a proportion. 4 over 25 should be the same as, okay, now notice, they gave us the area of the smaller pentagon, smaller. So 30 should go where the smaller number goes. We don't know how big the area of the larger pentagon is, but we know it's bigger than 30. Okay, just like 25 is bigger than 4. And so now I'm going to set up a proportion here. X will be the area of the bigger pentagon. 600, 750 maybe, I don't know. I don't know what 30 times 25 is. 750. Okay. So 750 equals 4x. Divide by 4. 18. 750 divided by 4, 187.5. So we find the area of the larger pentagon be 187.5 centimeters squared. And that's our answer. Okay, so important recap of the problem. We use the similarity, we use the corresponding sides to find the similarity ratio. We took the similarity ratio and we converted it to the area ratio because that's what we used. We made sure that we put the numbers where they belong. Smaller pentagon goes where the smaller number of the ratio goes. And then we solve the proportion. Okay. Last problem on this side. Let's try to set this up so I can keep the camera still. Alright. Example 3. The corresponding sides of two similar decagons are in the ratio 3 to 4. Given that the area of the larger decagon is 96 inches squared, find the area of the smaller decagon. Okay. Decagon. Does it matter that it's a decagon? Does it matter that it's a pentagon, a hexagon, a 12gon? Which is a dodecagon. I should have probably used a different number. No, it does not matter to the shape. Okay, remember, with similar figures, this is constant, so the shape doesn't necessarily matter. You can cross it out of your mind if you want to. Okay, they did tell us that the similarity ratio is 3 to 4. So that does matter. That's our similarity ratio. Okay, and I'll highlight it right here, even though you don't have to do that all the time, but for notes, maybe an important thing. Okay, now again, they're asking us for area. Okay, so I need to take this and make it to area. That's 3 squared over 4 squared, which is going to be 9 over 16. This is the area ratio. This is the one that we're going to be using. They're talking about area. Okay. Okay. So they tell us that the area of the larger decagon is 96 inches squared. That's going to be a part of my proportion. I know that 96 goes where the larger number is. I don't know how big the smaller one is, but I know it's smaller than the larger one. Okay, I'm just going to use y here. Cross multiply. 16y equals 864. I'll make sure. Don't want to be wrong on YouTube. Okay. And then divide by 16. And I should have kept the calculator up because I have no clue. 864 divided by 16, 54. Okay, and so the area of the smaller decagon is 54 inches squared. Alright, again, same process. Similarity ratio to area ratio to proportion, solve the proportion. Flipping to the back side. Going in a little bit different area or direction here. Example 4 says the area of two similar triangles is 98 meters squared and 50 meters squared. Find the similarity ratio and the ratio of perimeters. So here's where they started off and they said, hey, here's your areas. You got those now. 98 over 50. Okay. We need to find the ratios, both the similarity and the area ratios. Now what we'll do for that, since we're given the areas, and it's important to know that these are areas, since we're given the areas, we can find the ratio just by simplifying the fraction. Okay? And so let's simplify this fraction. That's 49 over 25, because they're both even, so I'm going to take 2 out of them. Okay, and now I know what I have on top is a squared, and what I have in the denominator is b squared. And so I can find out what a is by taking the square root. Well, first of all, if I have a squared and b squared, right, because I'm simplified, then I know that this is my area ratio. Oh, that's my area ratio. They're not asking for the area ratio. They're asking for the similarity ratio and the perimeter ratio. So I need to find out what my similarity ratio is. My similarity ratio, remember, will be a over b. So I need to take the square root. To get from a squared to a, I need to take the square root. Square root of 49, 7. Square root of 25, 5. My similarity ratio, 7 over 5. My perimeter ratio, the same, 7 over 5. No extra work there. Similarity ratio and area ratio are the same. Okay, next problem. The areas of two similar polygons, or sorry, parallelograms, might as well be polygons, are 1,875 feet squared and 135 feet squared. Find the ratio of their sides. What's the ratio of their sides mean? Remember, that's just another way to say similarity ratio. Not ratio. Ratio. Okay, and so they gave us the area, 1,875 over 135. We simplify that. 1,875 over 135. See if I get a decimal. Nope. Okay, and so I'll do 1,875 divided by 5. That gives me 375. That divided by 5 gives me 27. Okay, so then I know I can divide that by 3. Oops, let me move this out of the way so you can see my work as I do it. Okay, so I divided both of those by 5. Make sure I did that right. Divided by 5 is 27. Okay, and now I'm going to divide those by 3 because I can see that 3 goes into both of those. 375 divided by 3 is 125 over 9. 27 divided by 3. Alright, and then, is that it? Okay, nothing goes into both of those. 3 doesn't go into 125. Okay, so there I am. Now what I'm going to have to do is take the square root of these. It's the square root of 125. Yeah. Square root of 125. Okay. I will just do it like this because I don't like that number. So what goes into 125? 25 times 5. I'll break it down here. 25 times 5. 5 and 5. So my answer here will be 5 radical 5. And the square root of 9 is just 3. So the ratio of their sides is 5 radical 5 over 3. And that's the answer. Okay, not a pretty number, but not too bad when you simplify or use simplified radicals instead of decimals. Okay, final example of the chapter. The area of two similar hexagons is 324 centimeters squared and 64 centimeters squared. Assume the perimeter of the smaller hexagon is 26 centimeters. What is the perimeter of the larger hexagon? Okay, so here's what this question's asking us. First, use the areas to find the ratio of areas. Use the ratio of areas to find the ratio of perimeters. Use the ratio of perimeters to find the perimeter of the larger hexagon. Okay, so a packed question. So we have 324 over 64. Before we simplify or try to take the square root, we're going to simplify the fraction. So 324 divided by 8. Nope, doesn't go nicely. 324 divided by 4. 81. Okay. So I'm going to divide that by 4. That gives me 81. 64 divided by 4, 16. Okay, this will not simplify any further. And so, since this is areas, I know that this is a squared over b squared. A squared, that means a square root of 81, which is 9. B squared is 16, which is 4. This is my area ratio, or ratio of areas. This is my similarity ratio. Remember that the similarity ratio will be the same as my ratio of perimeters. Okay, so I'm going to use this ratio, 9 over 4, to find the perimeter of the larger hexagon. They said we're assuming that the smaller hexagon was 26 centimeters. I know the smaller hexagon goes with the smaller number. Don't know the perimeter of my larger hexagon, I'll use z there. Okay, so 4z equals 234. Make sure that I'm right. 9 times 26, 234. Divide by 4 to find z. And z is going to be 58.5. And so what's the perimeter of the large hexagon? 58.5 centimeters. Just to be nice. Okay, so that is using similarity ratio, area ratio, ratio of perimeters. Being able to convert from one ratio to the next and being able to use those ratios in order to find missing information no matter the type of polygon. Okay? Alright, see ya.